Hello friends, welcome to my channel Technical Arquen, myself Arnab Kundu. Today I will discuss a topic, and the topic is that what is self-referential structure. Now when we define what is self-referential structure, actually when a structure contains one or more pointer which points to the same structure own kind, or we can say the pointer which points to the same structure itself, then this structure is called self-referential structure. So go to the computer screen, step by step I will discuss self-referential structure, and also I will code in C language to describe this particular topic, self-referential structure. Okay. So friends, today's topic is self-referential structure. So what is self-referential structure? Today we will know in details. Okay. So at first we can say when a structure contains one or more pointer which points to the same structure of own kinds, means it points to the same structure itself, then we can say this type of structure is called self-referential structure, which can use within the C language. Okay, so I will discuss this topic in depth. Okay, so what is self-referential structure? Self-referential structures are those structures that have one or more pointers which point to the same type of structure as their member, right? A structure can have members which point to a structure variable of same type, right? Means whatever the structure itself. Okay, a structure definition which includes at least one member that is a pointer to the structure of its own kind. Okay, these type of structures are called self-referential structures and are widely used in dynamic data structures like trees, linked lists, graph, etc. Right? The following is a definition of a self-referential structure. So this is actually the way to write a self-referential structure in C language especially concerned. So just write struct note, then within these braces we are defining a normal data type, means int data, and then we are defining a pointer which is the same type of the structure itself. So that's why write struct note asterisk next. So this is actually the node is concerned, means when a node is there, one part is your data, means information, and another part is a pointer which points to the same type of address, here the node 2. So that's why this next is actually pointing the same structure type. So this structure is called self-referential structure, right? And here next is a pointer to a struct node variable. Okay. Now the concepts of self-referential structure. The concept of self-referential structure is based on the idea of a linked list, okay, which is collection of data elements that are connected to each other through a series of pointers. Each element in the list contains a data value and a pointer to the next element in the list. The picture just so that each and every node contain one is data, other is an address which points to the same type of node is concerned. Okay, this creates a linked structure where each element is connected to the next one. So this is a singly linked list, just defined as a diagram is concerned. There is a head node which contain this node address, suppose it is 100, and that's why you go into that particular node which contain a data is a 6, and again the address of the next node is a 300. Next go to the next node, 9 is a data, 400 is the address. Similar manner when we go or when we reach the last node, it contains the data with the next part is the null, means there is no more node is connected with that linked list is concerned. Okay, I hope you have understood the theoretical part of how a self-referential structure is defined. Now I am showing through CIDE the one of the example of singly linked list through a proper coding, right? So go to the computer screen and through a particular IDE I will write the code for self-referential structure. Okay. Now friends, I am just within the dev C++ IDE, and here I am just writing the code for the C language is concerned, means here we write the C code for create a singly linked list. Okay, so at first we write the header file, so just write here hash include and then just write stdio.h. Okay, again we include another header file hash include stdlib.h, because we are declaring here runtime memory allocation, so that's why we need this header file stdlib.h. okay, now we are defining a structure. Now we are defining actually here self-referential structure. Just write struct node, and after within this brace we are write their data member. Just write at first int data, which is a normal integer. Now we write the pointer which points to the same structure itself. Okay, struct node asterisk next. So this is a pointer which point to the same kind of structure, means itself it is pointing. Okay, so that's why this structure, the struct node, is actually a self-referential structure. Okay, now what happened, we are just defining some code within there, and then I am just writing here int main from where the program will start. So within brace just write at first struct node, we are defining some variable, the pointer, the head, and initialize its value null. Okay, same way define another pointer of the same type of the structure, struct node asterisk, suppose here write second, and same way we define its value null, means we are initialize this value as null, and another pointer which is also the same pointer which point to the same structure, and the variable name is suppose third, and also initialize its value as null. Okay, and after we are defining the runtime memory allocation here, the function malloc. So just write head equal, and within parentheses just write struct node asterisk, and then just write here malloc, and then we are just write here size of, and just write struct node. Okay, and same manner we are just copy it and same manner we are defining these three head, second and third for the memory allocation is concerned. Okay, now after what happened, we are just do the link, means now we are linked the nodes together. So just write here at first head arrow data equal, suppose the data is suppose A at first. Okay, and same way second arrow data, suppose it's suppose B. Okay, and third arrow data, suppose it is C. Okay, so these three data is there because three node we are already defined. Okay, and after connect each and every node, so that's why just write head arrow next equal second, and next we write second arrow next equal third, and at last write third arrow next equal null, because this is the last node. So last node next pass is null, means after that there is no node is there. Okay, so at first we are defining the data in the data part, and in the next part we are just defining what, we are defining the address for the next node is concerned. Okay, and the last node contains the null part in the next part. Okay, Now after that, what we have traversed the linked list from at first to the last. Whatever the data present within the linked list, in a single linked list, we are just traverse. Okay. Now after that, we just traverse the single linked list using some other code. Means whatever the data we are put into there, we just traverse. Okay. In that case, what happened? We are again just declare another structure pointer, which is also a define the self-referential part. So just write struct node, just write asterisk current, and just write equal head. Okay, means it just contain the head address. Whatever the head contain the address of the node, it just contain that. Okay, because we are traversing the linked list from the first node to the last node. Okay, and after we just write here while and just check the condition current not equal null, because we know the last node contain the next part is null. Okay, so this is our condition, and just write within a braces and just write here. So at first we print, so just write printf and just write within double quote %d, and after we just write comma and then just write current arrow data. Okay, because the data contain the information like ABC, etc. Okay, after we just write here current equal current arrow next. Okay, and this is the end of this while, and before ending this main, we just write here return 0. Okay, now we just save that code. So just go to the file and just save, and suppose we put the name of that particular file is linked underscore list, and the type we just choose as a C source, because we write here the code in C language, so that's why the extension should be .c, and save it. So we already saved this file within the file linked underscore list.c, because this is a C program, so the extension should be .c. So you just go to this button, this is compiled and run, or we can directly press F11 from the keyboard. Okay, so just click it, just see, it just print what this particular integer part. Okay, so now what happened? Why integer? Because for A, B, C, the ASCII value is this 65, 66 and 67. So if you want to know this character, so we just change here in the printf part, we just write here C. Okay, because the %d convert the character into respective ASCII character in integer 65, 66, 67. Now if we change this control string into %c, now we get ABC. Okay, again compile and execute. Yes, we get ABC as output. Okay, I hope you have understood today's video. Today's video is very simple. What is self-referential structure and how we can write this code in C language. So this is the code, this is the structure which contain a pointer struct node asterisk next, which points to the same structure itself or its own kind. So this type of structure we can call self-referential structure, which point itself. Okay, I hope you have understood today's topic. If you still have some doubts, just write in the comment section this video. I will try to solve your problem. If you have not subscribed my channel till now, please subscribe it. Keep watching Technical Arquen and share it and like the videos. So keep watching Technical Arquen for upcoming videos. So today up to this. Thank you and bye bye.